Hello, Year 8. Okay, so today we're going to be talking about acids and carbonates. So the way this links to the work we've done previously is before we were talking about, if we go back, we were talking a lot about pH, so we're talking about acids and alkalis. Then we were talking about neutralization reactions, so the reaction between an acid and a base. And remember, an alkali is just a base that's dissolved in water. And we had all these different reactions, so an acid plus a base gives us salt and water, and we spent a lot of time thinking about how we name those salts. All right, so today, rather than do acid plus base, we're going to do acid plus metal carbonate. All right, so we'll see how that works. So, first of all, we need to think about what a carbonate is. Now, a carbonate is a compound that contains CO3. Okay, so C, one carbon atom, O3, three oxygen atoms. All right, and that is our carbonate. So, some examples of carbonates would be, we could say CaCO3. Okay, so Ca, that's our metal, that's calcium, and I've got one of those, and then I've got one carbon and three oxygens. Now the way we name these is the same way as we named everything before. So we take the name of the metal, calcium, okay, and you'll remember from before that if we had, if it was a chloride salt, it meant it had Cl in it. And if it was a nitrate salt, it had NO3 in it. And if it was a sulfate salt, it had SO4 in it. Okay, now we've got CO3. So it's Ca, calcium, CO3, carbonate. Nice and easy. Okay, we could also have MgCO3, which is obviously going to be magnesium carbonate. And these, it's not always just one metal atom, so we could have, for example, Na2CO3. All right, so now I've got two sodium atoms, one carbon, three oxygens. So that's going to be sodium carbonate. Okay. Now these are all generally going to be, they're all white powders. White powder. Okay, so you might have heard of sodium bicarbonate, or baking powder, baking soda. You might have some of that in your kitchen. That's similar to this. It's not exactly the same. It's a little bit similar, but it would look very similar in appearance. But the formula is slightly different. All right, so what happens when we do a reaction of one of these carbonates and an acid? So let's imagine I've got here, this is my white powder, let's say it's CaCO3, which would be calcium carbonate, and I'm going to react that with some hydrochloric acid. So in here I've got HCl. All right, and I pour the HCl in, and there's a reaction. Now, usually in the lab, I would do this reaction, and you would be able to see fizzing, and you would see a gas coming off. All right, so there would be fizzing and a gas released. Now, the reason it fizzes is because the gas is released. So, what's going on? What's happening in this reaction? Well, we have our calcium carbonate, so our CaCO3, which is calcium carbonate, plus our HCl, which is our hydrochloric acid. And that is making, it's going to make a salt. So the same way that we had a salt in our acid and our base, we're going to make a salt as well. And we get the salt exactly the same way. It's the metal, so it's going to be calcium. Okay, and then because it's hydrochloric acid, the salt it's going to make is going to be a chloride salt. So it makes calcium chloride. Now the formula for calcium chloride is actually CaCl2. And then I get two other things. I also get H2O, water, plus CO2, which is carbon dioxide. Okay? And it is this carbon dioxide here, the carbon dioxide, this is what is released as a gas. All right, so this gas here, the one that you see coming off when we do the reaction, that is carbon dioxide. Okay, so first things first, is this equation balanced? Doesn't look like it, so if you pause the video now, you can have a go at balancing that equation. Okay, so that should have been fairly straightforward. Everything's balanced except for we've got two hydrogens here and we've got two chlorines here, so we need to have a 2 in front of there. Okay, now when we do this experiment, I'm just telling you that this is carbon dioxide that's released. You might not believe me, okay, which is fair enough. But there is obviously a test that we can do to check whether or not this is carbon dioxide being released. A test which you should remember, but I'm going to remind you of it now. So let's suppose, instead of doing it like this, where we do it in a beaker and the gas comes off, we're going to do it in a experimental setup like this, okay, where I have my my reaction in here. Okay, so this is my reaction. All right, and that's going to produce a gas. And the gas is going to come along here, along this tube, down here. And then what I'm going to do is I'm going to pass it into a test tube, which is filled with lime water. All right, and you'll see bubbles of the gas going through the lime water. All right, now when we do this experiment, we do this test, so the gas comes off, it bubbles through the lime water. If the lime water turns cloudy, then we know that the gas is CO2. So that's the test that checks whether or not the gas really is CO2. All right, so that's a key thing from today's lesson. All right, the other key thing is that you need to know this general formula up here. All right, so we have here metal carbonate plus acid gives us a salt plus water plus carbon dioxide. And guess what I'm going to say? Yep, of course, get yourself a flashcard. Metal carbonate plus acid, salt, water, carbon dioxide. All right, and add that to your collection that you should be testing yourself on regularly. Okay, so let's do a little bit of practice for this. So up here, I've written out an equation, and what I would like you to do is pause the video and do two things. The first thing I would like you to do is to balance the equation. And the second thing is to write underneath a word equation. All right, so balance it and then write a word equation. Okay, so to balance it, you should have done this. You should have NaNaCOOO. That's my carbonate, plus HCl goes to NaCl plus HHO plus COO. Okay, so straight away you can see that I've got two sodium atoms here. I've only got one sodium atom here, so I'm going to have to add in another NaCl. Okay, now I've got two Cl's here, but only one Cl here, so I need to add another HCl. Now, I can have a look. So I've got two sodiums, one carbon, one carbon. I've got 1, 2, 3 oxygens, 1, 2, 3 oxygens, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. So it's balanced. So one of those, don't need to write anything, 2 of those, I'll put a 2 there, 2 of those, 2, 1, 1. So that should be your balanced equation. And then underneath, you should write the word equation. So quickly pause it now if you haven't done that. Otherwise, it is going to be sodium carbonate plus hydrochloric acid gives you sodium chloride plus water plus carbon dioxide. Okay, so I would like you to have a go at another one, and this one I would like you to have a go at is Na2CO3 plus HNO3 goes to NaNO3 plus H2O plus CO2. So again, I would like you to balance the equation and write underneath it what the word equation is. Okay, so if you've balanced it, you should have got this, a 2 in front of the HNO3, a 2 in front of the NaNO3, and then the word equation would be this. Okay, so sodium carbonate, the same as above. Now we have HNO3, which you should remember is nitric acid, and you'll remember that nitric acid gives you a nitrate salt. So we take sodium from the carbonate, and we take nitrate, because it's nitric acid, and we get sodium nitrate. Okay, right. There'll be more of those to practice in the next bit of work.